Hi folks, welcome back. I hope you're all doing well. So by now there have been a few systems that do search and indexing on your own private corpus, but use LLMs in the mix. They use LLMs to synthesize answers to queries on your own corpus, a corpus that was not in the training set of these LLMs like GPT-3. One example of this is Llama Index or GPT Index. Another one is Paper QA. Simon Willison has a great blog post explaining how a system like this works, and it's even mentioned in the OpenAI cookbook on GitHub. They have a dedicated entry explaining how question answering using embeddings on LLMs works. And recently, Steve Yegi wrote a great blog post about how Cody, which is their version of Copilot, uses the same technique to offer completions on very large code bases. So today I thought I'd take a look at what exactly this design pattern is of doing information retrieval with LLMs and compare it with the traditional or old school way of doing search. So if you look at the traditional way we do information retrieval or search, you have a bunch of documents and then you have a user that's trying to write queries over those documents. And the way we accomplish that is by building a data structure called an index. Now, before indexing, we break every document down to the words that it contains. And the index is essentially a giant map from words to the documents in which that specific word occurs. Now, say the user's query consists of these two keywords, blue and sky. You go look up the index for the word blue and the word sky, and that will give you back a list of matching documents. And then once you have all these matches, you put them through some kind of a ranking mechanism. In the case of the web, the famous one is PageRank. And then you rank all these matches and you present to the user your results page. Now let's look at how search or information retrieval would work with an LLM as part of the system. So you still have a user trying to write queries against a corpus of documents. But now we can write queries that are not simply keywords. We can actually write higher level questions in natural language. And the new and interesting thing is that you get back not just a list of ranked matches, but synthesized answers in prose, in natural language. So we saw that the entire information retrieval process has these three big components to it. You have indexing, searching, ranking. And index maps words to the documents in which they occur. Searching consists of looking up this index with your query to get matching documents. And finally, ranking gives you a prioritized list of these matches. Now, what's happening in this new style of search is that for the index data structure, we use something called a vector embedding. And for searching, rather than looking up an index, we search our vector embeddings not for exact matches, but for vectors that in this vector space are the nearest neighbors to our query, also expressed as a vector. And then for the ranking phase, we don't really have ranking per se, but we prompt an LLM. So we've got these three steps in this new style of search. We perform a vector embedding. We do search with nearest vectors over those vector embeddings. And then we prompt an LLM with what we found. So let's look at those in a bit more detail. Now, you might ask, why go through all this trouble? The reason we're trying to do all this is that we have to fit all this context or the parts of our corpus that are interesting that are related to the query into a very small context window. The context window is essentially the size of the prompt that you can give an LLM. For GPT-3, it was about 4 kilobytes. For GPT-4, it's much larger. It's 32 kilobytes. but that's still pretty small compared to most realistic corpora that you want to search over. All right, so to start with, instead of breaking your document down into words, we decompose it into semantic chunks. And what these chunks might be is up to the application or up to the system that you're building. It could be paragraphs, it could be sections, it could be chapters, but it's something a bit more higher level than just a bag of words. And then for each of these chunks, we do a vector embedding. Now, how exactly vector embeddings work and how they're created is a topic for probably another video, but I'll leave some links that explain it down in the description. But at a very high abstract level, what's basically happening is that you're taking the words in each chunk and transforming them into some very high dimension, k-dimensional vector. And all these vector embeddings get stored in what is called a vector database. You might have seen some of these things like Pinecone. And then when it's time to query, you embed your query as well. Your query is also a natural language sentence. And then you look up the vector database for the n nearest vectors to your query. So one of the cool properties of vector spaces is that there's a well-defined notion of a distance between any two vectors. So we take our query, we convert the query into a vector as well, and look up the database for the closest vectors to our query vector. And what that gives us back is similar to what we saw in the indexing case, which is a list of chunks, the original chunks into which we had broken up our document, and the documents in which those chunks occurred. And now we have to take the top few of these chunks, as many as will reasonably fit into our context window, and concatenate our natural language query to these chunks. And that entire piece of text becomes our prompt to the LLM. And so what you've got at the end of this whole process is chunks of text that are semantically close to the query you were asking, along with your query. And that's what you're asking an LLM to analyze and give you back an answer for. So the vector database and the vector embedding is a mechanism to take your large corpus and be able to give you back just the few semantically related chunks that are related to your query. And that then goes into a prompt to an LLM, which is able to synthesize an answer to your query. So that was a high-level overview of how this entire information retrieval pattern works with vector databases and LLMs. There are many folks who have made great videos about how this works at the code level. I'll link to some in the description below to give you a more concrete idea of how this actually gets coded up. I hope you enjoyed that. If you haven't already, please subscribe. If you find these videos helpful, please like, leave a comment, and I will see you next time. Thank you very much.